Now that we know what a mixed strategy is, we need to revisit the idea of dominant and dominated strategies. Recall that a strategy is strictly dominant if it is a strictly best response to every strategy the other player could play. Sometimes you also read that a strictly dominant strategy is a strategy that gives the best result for a player no matter what the other player plays. However, while this is not wrong, it can be confusing, because as we know from the prisoner's dilemma, the outcome that results from playing a dominant strategy can be Pareto inefficient. It is true that if you take the other's strategy as given, a dominant strategy always gives the best outcome, but I prefer to speak about best responses, as this creates less confusion. So check out the game on the right. Do you see any strictly dominant strategies? As you can see from the payoff matrix, down is a strictly dominant strategy. If player 2 plays left, down gives player 1 a payoff of 4, which is higher than what player 1 could get by playing up or middle, and the same is true for center and right. Furthermore, right is a strictly dominant strategy for player 2. If player 1 plays up, player 2 can secure a payoff of 3 by playing right, which is higher than the outcome of playing left or center. And again, the same is true for middle and down. If both players have a strictly dominant strategy, there exists a Nash equilibrium in strictly dominant strategies. So in our example here, the Nash equilibrium in strictly dominant strategies is down-right. If all players have strictly dominant strategies, a game does not have a Nash equilibrium in mixed strategies. This is because every player plays their dominant strategy with probability 100%, so the players do not mix their strategies. Closely related to dominant strategies are dominated strategies. Recall that a strictly dominated strategy is a strictly worse response to every strategy of the other player than another strategy. Again, check out the game on the right. Do you see any strictly dominated strategies? Up is strictly dominated by down. As you can see, no matter whether player 2 plays left, center or right, up always gives a lower payoff than down. And likewise, the strategy center is dominated by the strategy left, as it gives player 2 a lower payoff than the strategy left, no matter what player 1 is playing. If a game has dominated strategies, it may be dominance solvable by iterated elimination of dominated strategies. So, is the game on the right dominance solvable? The answer is yes. So first we eliminate the dominated strategy up, then we eliminate the dominated strategy center, and now we can see that the strategy right is dominated by the strategy left, so we eliminate right, and finally down is dominated by middle, so we eliminate down, and we are left with a Nash equilibrium middle-left. How about this game? Does the game on the right have any strictly dominant or dominated strategies? At first sight, your answer to this question is probably no. However, this is actually wrong. You are correct in saying that there are no strictly dominant or dominated strategies in pure strategies. However, there is a pure strategy which is strictly dominated by a mixed strategy. Consider the strategy middle. Although middle is neither dominated by up nor by down, it is in fact dominated by a mixed strategy of up and down. As you can see, the payoff from middle is always lower than either the payoff from up or down, and in fact there exists a probability combination such that the expected payoff of a mixed strategy of up and down is always higher than the payoff of middle. For example, if player 1 played up with probability 50% and down with probability 50%, this would create an expected payoff of 4 if player 2 played left, because 50% times 2 plus 50% times 6 is 4, and it would yield an expected payoff of 3 if player 2 played center. 50% 1 plus 50% 5 is 3, which is higher than 2. And the same is true if player 2 played right, because the expected payoff of 50% 7 and 50% 3 is 5, which is higher than 4. So therefore, middle is dominated by the mixed strategy 50% up and 50% down. There are in fact more mixed strategies that dominate middle, not just 50% 50%, but it is usually a good start to test 50% first, because that's fairly easy. Okay, so now since the mixed strategy of 50% up and 50% down dominates the pure strategy middle, we can eliminate middle from the game. So are there any more dominated strategies? Center is dominated by a mixed strategy of left and right. Again, we can try 50% and we see that it works, because the mixed strategy of 50% left and 50% right gives an expected payoff of 4.5 if player 1 plays up, and an expected payoff of 3.5 if player 1 plays down, which in both cases is higher than the payoff of center. So we can eliminate the strategy center from the game. Are there any dominated or dominant strategies left? The answer is no. So we are left with a 2x2 game. What are the Nash equilibria of this game? First, we look at the best responses and we see that up right and down left are Nash equilibria in pure strategies. Is there also a Nash equilibrium in mixed strategies? The answer is yes. Remember, to find the Nash equilibrium in mixed strategies, we need to make sure that the players are indifferent between playing their strategies. So we set the expected payoffs of up and down and left and right equal and solve, and we get p equals 1/2 and q equals 1/2. So the mixed strategy 1/2 up, 1/2 down, and 1/2 left and 1/2 right is a Nash equilibrium in mixed strategies here.